Hi, everyone. Welcome. I'm Priya Natarajan. I am the director of the Franke Program in Science and the Humanities at Yale. And I'm also an astrophysicist with appointments in the physics and astronomy departments. So mapping has been a subject that has informed my scientific work and has been a theme that many of us in astronomy, of course, have eternally been involved in. But over the last few decades, mapping has been used both as a metaphor and for literally mapping things that we see and know. So inspired by sort of the changing definition of mapping, we in the Franke program decided to focus on trying to understand contextually what mapping means today across disciplines. And as part of that, we started this new series called Mapping as Knowing. And we have invited several scientists, artists, writers, thinkers. We have a program that's unfolding over the entire academic year, addressing this issue of what maps teach us, what they encode, what their limits are, and what are the new ways in which we can push maps and learning from maps. So it is with great pleasure today that I would like to introduce our speaker in the series, Dr. Eric Sanderson. He's the third speaker in this series. And to just give you a very brief recap of the trajectory, the arc of how we have been tackling mapping so far, we started off with Professor Matthew Edney, who is a very eminent cartographer, who drew attention to the limits of what mapping can do and what is encoded in maps that actually limits our understanding. It encodes how we think at any particular time, but that also imposes mental limits on what can be mapped at a given time. So if you look at colonial maps versus maps today of the same terrain, so if you look at a cartographic map, they encode very different things. And the second speaker in our series was Dr. Phyllis Frankel, who talked about the purposes maps actually serve in science and engineering today. They serve not just as tools of visualization, but as avenues for innovation. So keeping with sort of this roving theme of mapping, today, we have Dr. Sanderson, who will be talking to us about mapping time and space together in this sort of fantastic visionary project that he's been leading for several decades now, which has been mapping the past, present, and future of nature in New York City. So this kind of conflict, if you will, or conversation between ecology and urbanism over time, and how that's played out in this sort of one piece of coveted real estate in the world. But before I tell you more about him, I want to thank Richard and Barbara Franke, who have generously supported the program and are supporting this series. And I'm absolutely delighted to see Richard here in the audience this evening. So first, and before I forget, we have a fabulous reception outside in room 108 following the talk. So please do stay for that. So Eric Sanderson is a senior conservation ecologist at the Wildlife Conservation Society. His PhD is in ecology with a particular focus on ecosystem and landscape ecology from the University of California, Davis. And starting at the Wildlife Conservation Society in 1998, he has established the Landscape Ecology and Geographic Analysis program to bring landscape thinking and geographic analysis tools into the conservation practices. In 2002, Dr. Sanderson and his colleagues created the Human Footprint Map, the first look at human influence globally at less than 1 square mile resolution. I highly recommend you going to his webpage and looking at some of the wonderful visual material that he and his colleagues have been creating. He's also an expert on species conservation planning and has contributed to efforts to save lions, tigers, Asian bears, jaguars, tapirs, and peccaries, American crocodiles, North American bison, and it goes on and on. And landscape planning conservation efforts across the world in Argentina, Tanzania, Mongolia, and the greater Yellowstone ecosystem closer to home, and the Adirondack Park and on the East Coast. He has edited 2 scientific volumes and written numerous scientific papers. His work is amply featured in the media, and I would be surprised if you haven't actually come across him or his work in the New York Times, National Geographic Magazine, CNN, or the New Yorker. He is also the director of this wonderful project that we are going to be learning about today, the Mannahatta Project, which is an effort to reconstruct the original ecology of Manhattan Island, starting from the time of European discovery in the early 17th century to today. So in 2009, he published this wonderful book called Mannahatta, A Natural History of New York City, of which I have this copy here. Highly recommend that you get it. It has really beautiful illustrations. And he curated an exhibition based on this project, and which is on display at the Museum of the City of New York. And he also, as I mentioned earlier, has this website that allows the users to, so it's a very wonderful user-friendly website where you can navigate and learn and actually look at the transformation of the landscape. So without further ado, I would like to invite Dr. Sanderson up.
Thank you so much, Priya. Thank you for that wonderful introduction. And thank you all for coming out in such a dreary afternoon to hear a story about mapping. And I kind of hope that maybe there's three aspects that I can contribute to this seminar series about mapping. One is, as the title says, this way of thinking about how nature in one particular place that matters to a lot of us, New York City, how that has changed over time and how it might change into the future. The second thing I hope you'll take out of this is the ways that maps really go beyond a physical piece of paper with lines and colors on it, but actually all the different ways that we think of mapping today and all the ways we can use technology and to map and see our world. And then the third part is the sort of personal story for me of how maps are a really important part of my life. And I think it really comes out in this process. And they've been a huge and valuable way for me to sort of conceptualize and see my role in New York City's nature. So without more ado, I want to take you to this place. This is Manhattan Island. And I would like you to imagine if we could go into a time machine and go back 400 years to when Henry Hudson was first sailing into New York Harbor. What might we have seen? And we might have seen something like this. I hope you can make that out. This is a rendering of Manhattan Island on September 12th, 1609, about 2 o'clock in the afternoon. There's a little ship. I don't know if you can see the ship in the Hudson River there. That's Henry Hudson's ship, the Half Moon. Through our research, we've come to understand that this island had 54 different ecosystem types, 54 different ecological communities, maybe 1,000 different species were living there, including people. There have been people living in the New York City region for about 8,000 years. And I don't know if you can see the smoke rising from one of their settlements down in lower Manhattan along the Collect Pond. So this isn't an unpeopled wilderness. This is a place where people have been living for a long time and enjoying the landscape. For the Lenape people, which were the most recent culture for me, 2.5 times as long as European people have been there. And they called this place Mannahatta, or the Island of Many Hills. We finished our work on Mannahatta in 2009 when this book was published, and subsequently been working on the rest of the city. I won't talk about this so much tonight, but I just wanted to mention, if you ever see Wilikia, or if you go to our website, you'll hear this term. It's another Lenape word, and it means my good home. And that's exactly how we want people to see this environment, as a really good place for people to live, because nature has made it so. And then finally, toward the end of my presentation, I'm going to talk a little bit about a new platform that we've constructed based on the historical ecology that allows anyone in New York City to dream and imagine and construct and evaluate the future of their neighborhood, called Visionmaker.nyc. So my story has 5 acts. And the first part is about a map found. I don't know if you can tell from the way I speak, but I'm not from New York originally. I grew up in Northern California. And when I was a young person, I wanted to do nothing more than to be in the mountains. And I took this picture on the left, actually, when I was on the John Muir Trail when I was about 14 years old. And this way of seeing nature as something composed of ecosystems is what eventually led me to pursue a set of graduate studies in a field called landscape ecology. And to landscape ecologists, we look at a picture like that and we see different kinds of ecosystems in a configuration with each other. We see the stream beside the meadow, and the meadow beside the forest, and the forest beside that cliff in the distance. As if we were a bird flying over the meadow. And we think about how does that composition of ecosystems and that configuration make habitat for plants and animals, including for people. Most creatures live at the landscape scale, as we talk about. And landscape ecology is how we understand how those landscape patterns are made and how they're changing over time. And once you sort of get that idea in your head, that any landscape has these ecosystems and they have an arrangement to them, like pieces of a puzzle, then you can start to see that everywhere. You see this in Canyon de Chelly in Arizona, for example. You can see the shrublands on the side of the hills, the cliffs, and the valley in the bottom. And much to my surprise, knowing about this got me a job at the Bronx Zoo, at the Wildlife Conservation Society 20 years ago this year, actually. And part of the reason why I agreed to take my career into conservation, and particularly in conservation in New York City, where I wasn't from, is because this place was founded by these conservationists of a previous generation, like Teddy Roosevelt there on the steps of the Bronx Zoo administration building. Teddy Roosevelt helped save those places, helped conserve those landscapes in California that I grew up loving so much. And so I thought, well, maybe I can walk in his footsteps. And then, much to my surprise, they gave me an office in this building. So I was literally walking up these steps every morning going to work, thinking about Teddy Roosevelt. But whereas my work is through the zoo and through the Wildlife Conservation Society, it isn't actually about the animals in the zoo, but actually I was hired to help WCS think at the landscape scale all over the world, whether it's for jaguars or rhinos or spectacled bears in Latin America. And so I had this sort of itinerant existence for the first 5 or 6 years I was with WCS, flying all over the world, going to extremely wild places, seeing really extraordinary people, doing some really interesting things, and then flying back to New York. And this is a picture from that first summer in 1998 that I was in New York City from the top of the Empire State Building. And I was, trying to figure out, what am I doing here? What is Eric, the Californian, the person committed to wild places doing in arguably the most influenced place, the most dramatically changed place in the world? And can the ideas that, that I talk about all the time, landscape ecology, can it actually apply to a city? Can we actually see those buildings as a kind of ecosystems, as the streets as a kind of ecosystem, as the park and the river in the distance as part of that landscape configuration? And how does that pattern make habitat for plants and animals, including for people? How did it come to be? I think it's hard to walk around in Midtown Manhattan and not be sort of overwhelmed by the sheer monumentality of the place. Something else that struck me when I moved to New York is how much New Yorkers talk about the future and are disconnected from their past. Which is to say that people come, a lot of people come to New York because they want to make a new life for themselves or for the world, whether that's in business or in media or in the arts or even in the sciences. And there's all these kind of odd, weird things about New York City that don't make any sense except in their historical context. So this is another one of those snapshots. This is in Times Square. And, I was taking a picture of the advertising on the wall, but who's that guy standing on the statue there? Well, that's Father Duffy. Really important. He was a priest. He worked in Times Square in the late 19th, early 20th century. We wouldn't have Times Square as we do without Father Duffy. And he's right there in the middle of Times Square, and nobody ever remembers him, right? It's this odd thing about New York, which is so different than other great cities around the world. If you go to London or Paris or Tokyo or, Delhi, you feel as part of this sort of long tradition of people. That there have been people there before you that created that landscape, and there are going to be people after you, and you're sort of part of this historical tradition in a way that New York City just doesn't have that sense of itself, which, of course, is an opportunity. Because the signs of that old history are everywhere around us. These rock outcrops in Central Park here are Precambrian era rock formations. They're part of the original North America craton. They're 1 billion years old. They're older than life on Earth, right? Or if you see, I don't know if you can see a little bit of the topography here in Central Park, that's the original topography, modified some by Olmsted and Vaux, but the original topography of the island of many hills. And then if you think of those buildings south of 59th Street as a kind of hill, well, the island's way hillier now than it ever was 400 years ago. One of the things I do when I come to a new place and I want to learn about it is I read its history. And I read that New York City was the first megacity on the face of the planet, a city of 10 million people or more. Up until 1950, there had never been such a thing. A place, not ancient Rome, not London in the 19th century. New York City in 1950 was the only place in the world where 10 million people were living in one locality. Today, there's between 25 and 30 megacities as we count. There might be 50, by the middle of the century. Urbanization has been such an enormous way of transforming human society over the courses of our lifetimes and over the courses of the lifetime of our children. So it just struck me that New York's experience as a megacity so early on, the pains and the pleasures of enormous density are a really important story to tell. But to get to that story, we have to sort of see through it to the landscape that was there before. And, I'd be reading these history books, and then they'd have like a little black and white picture, where I saw this image for the first time. Does anybody know this place? This is, if you know New York at all, this is 125th Street, underneath the West Side Highway, where the Fairway Market is. If you're going down to see your friends at Columbia University, you might get off the highway here. Well, there used to be a beach there. This painting is by Victor Gifford Audubon, John James Audubon's son. It's from 1841. That's John James sitting on the rock here, watching the men bring in the fish from the Hudson River. And we're looking to the north, up Washington Heights, that wooded eminence, and that point of land you see there, that's Jeffrey's Hook, where the George Washington Bridge goes across to the Palisades today. And I thought, in all the thousands of things that are written about New York City every year, how come nobody ever mentions the beach that used to be there, or the forest, or, the way the land juts out there? How come we've forgotten this part of our history? If we go back even a little further, this is an engraving from the 1760s, so before the foundation of the United States. These are two students from King's College, now Columbia University. They're sitting on a hill overlooking a valley in Soho, right? And I would literally go on my weekends and look for that hill, and I can tell you it's not there. You can walk all over Soho and you will not see that hill, nor that valley, nor that palm tree. And for years I wondered about that palm tree, and then I read a little account of Davies, the man who made this. He was an engraver, and apparently he sent his drawing back to London to be engraved in the 1760s, and the engraver thought, this composition needs a vertical element. And so he added a palm tree because it's from America, right? Because America's, a place where palm trees grow. It was in the midst of this sort of, trying to figure out what I was doing, living in New York City, that I was in the Strand on 12th Street downtown, and I was thumbing through some of their New York City books. And there's a great book called Manhattan and Maps that had been published the year before I came to the city in 1997. And it's a book of maps that aren't very well known about the city. And it was in that book that I saw this map, which is the British headquarters map from 1782, 1783, made by British military cartographers during the war for military planning purposes. This is the kind of thing that Professor Edney might have shown you. I'm showing you Manhattan on its side, so that's those sort of pink blocks over there. That's the city in the 1780s. And if you look carefully, you can see the bowling green, the sort of green circle, and then it says Town of New York, that's Broadway, and then there's a little pink triangle there, that's City Hall Park. So the entire city was basically Bowling Green to City Hall Park, about a 20-minute walk during the American Revolution. But what's north of that is what got my attention. That pond, that lake in lower Manhattan, the marshes beside it, all these hills, all these streams. What are all these streams doing? You know, this was mapped for military planning purposes. You know, like where to deploy your cannon, where to send your soldiers, you know, this sort of thing. But as an ecologist, I was like, oh, you know, I'm seeing these fundamental aspects of a landscape, right? The hydrology, the shoreline, you know, some sense of the ecosystems, the salt marshes and the freshwater marshes. And the map goes all the way up the island, you know, Central Park, the Harlem Plains, the 125th Street Gap, that beach I just showed you, all the way up to northern Manhattan. And a few years later, I actually went to England and went to the National Archives, and after a big hubbubaloo, got in and turned in my little slip of paper, and they brought me the British headquarters map, which is 10 feet long and 3.5 feet wide, 6 inches to a mile scale. A really extraordinary document, a really beautiful, beautiful map. And so the first thing I said to them is, can I get a scan of this map? Can we take a picture of this map? Because if I can take a picture of this map, then I can pull it into my geographic information system, which is a technology for managing and mapping and taking care of data about maps, and I can georeference it to the modern city grid. I can actually relate these features we're seeing on the British headquarters map to their modern location. When Nick Baumgarten wrote about this in the New Yorker, he said this is sort of a naturalist version of George Washington slept here, right? Like, oh, there's a stream under my building. Oh, I guess that's why the basement floods every winter. Oh, you know, my house is in a salt marsh. Oh, Hurricane Sandy, that's why we have, you know, 6 feet of water on the first floor. You know, that sort of thing. And moreover, by georeferencing the map and then carefully tracing the features and then doing research to fill in what we could figure out about what was before the British headquarters map, we could make maps of the streams of Manhattan and the topography, the 573 hills and the 21 soil types. And these allowed us to reconstruct a new vision of home. You know, one of the things I love about Yale is there was an important ecologist, an English ecologist who worked here in the 50s, and he wrote a great book, a little short book called The Ecological Play and the Evolutionary Stage. And that idea is a fundamental idea in landscape ecology, which is to say that there are these physical factors about the landscape, which are the stage, that they're created by geological forces, by geographic forces, by climatological forces, even arguably by astronomical forces. Geology, topography, the watercourses, the shoreline, land cover, and that these allow us to derive a sense of the stage on which nature is going to play out its drama. And that drama is driven by disturbances, by factors, by catastrophes, things that reduce the biomass and the structure of ecosystems, things like fires and floods and land use and hunting and wind throws. And that if you know the combination of the stage and the drama, the disturbances, that you can start to make predictions about where the ecosystems were. That this combination of fire and floods and watersheds of this slope and this soil condition lead to a mid-reach stream, or a high salt marsh, or a chestnut oak forest, or all of the 54 different ecosystem types. I wrote a paper in the 2000s with a graduate student sort of marveling that there were so many different ecosystem types on Manhattan, you know, that come out of just putting these relationships together. 54 different ecosystem types on Manhattan. If you compare it to the vegetation map of Yellowstone National Park has 63 types and 2.2 million acres. Manhattan is 1/10 of 1% and it has 54 types. And you don't have to be much an ecologist to know that if you have a diversity of different ecosystem types, you're going to have a wide diversity of different species. So that led to a sort of sub-hobby of this larger hobby that I had, which was going to see these kind of ecosystems, most of which still exist around New York City in parks and preserves, if you know where to go look. That I could go to the Hemlock Northern Hardwood Forest in Orange County, And that would be like what the northern part of Murray Hill might have looked like 400 years ago. Or I could go visit the last little fragment of the Hempstead Plains grassland on Long Island. This is what Harlem might have looked like. Or see a coastal plain pond and see, well, this is what the Collect Pond in Lower Manhattan. Or this is what the Upper West Side might have looked like. Or that there were 66 miles of streams on Manhattan. And 25% of the island was marshes of one kind or another, most of which were these salt marshes with this sort of very structured landscape of mud flats and then low salt marsh and the high salt marsh, all driven by the tidal elevations. Or the 7 different kinds of forests. Or this is what Times Square might have looked like 400 years ago, a beautiful red maple swamp, home to black bears and wood ducks. Or the sandy beaches that the British headquarters map shows extended all the way from the tip of Manhattan up to 42nd Street. Or the ecosystems that people make, like wigwams. This is a wigwam that my son and I built at the New York Botanical Gardens many moons ago. He's much taller now. And it's, it's within the human ecosystems that the story about the Lenape sort of comes into the story, the ecological story, because we really can't understand how the landscape was disturbed by people. What were people doing? How were people living in this landscape unless we talk about them? So let me just tell you a few words about them. That they're an Algonquin-speaking people. They live from sort of southeastern, what we call southeastern New York, down across New Jersey into eastern Pennsylvania. They hunted, they fished, they grew crops. There's a really nice book by William Penn from the late 17th, early 18th century. William Penn knew the Lenape people, as he called them, and he was completely fascinated and a little bit bewildered by them. He'd say, take me to your leader, and they would just laugh, like, we don't have that, We don't have a king of the Lenape. They lived in these sort of small hunting-gathering groups that were independent, but also, knew each other and more or less got along. He would say, I want you to sign this piece of paper, this land deed. And they would say, what is that? When we tell stories, we just tell our stories. They obviously had a very rich and full culture, but it was a culture, an oral culture, not something about pieces of paper. And they'd say, sure, if you want to settle over there for a little while, that's okay. That's fine by us. There's lots of room. There's lots of room here. They had no idea that you could, they had no idea that this European idea that you could give away the land and own it forever. That would seem unconscionable to them. Something that was outside their imagination. The Dutch people would say, well, what about this seawant, this wampum? That's your money, right? And they would say, money? No, that's not money. Do you know how long it takes to make one of those things? Each of those beads comes from the purple part of a quahog shell, a clam shell that we find on the beach. And then it requires a bone awl to carve out that. And then to take another awl and put the hole through. Each one of those beads is hundreds of hours of work. This isn't money. This is a cultural gift. This is something I give to mark my respect to you. Really an extraordinary culture that really collapsed as soon as the Dutch showed up in New York. And I don't know if you know William Cronin's book, written here at Yale, about the sort of similar experience of the Connecticut Indians, but it's a really sad story. There are Lenape people still. Some live in Oklahoma, and some live in Wisconsin, and some live in New Jersey, and a few live up in Canada. But to go back to the amazing life they had on Manhattan, one of the things they did was they lit fires to manage the landscape. And we can't, know this from a map. We can only know this by modeling it, by actually using computer maps that are models of where fire goes. It turns out the U.S. Forest Service has a great model called Farsight that they use to predict where wildfires go. And you give it these inputs, the vegetation, the weather conditions, the topography, the ignition points, and then you get the outputs. You get fire intensities and fire frequencies. And we wrapped this in a spatial model that allowed us to map where all the fires were for 200 years on Manhattan Island. So we could get a sense of how fire impacted the ecosystems. We wrapped the disturbance model in what's called a succession model, which is what happens if you burn it today and then you leave it for 5 years, or if you leave it for 10 years, or you leave it for 15 years. What kind of ecosystems do you get? We also know that the Lenape were practicing horticulture. This is the traditional Three Sisters garden of corn, beans, and squash, a kind of symbiosis that was invented down in Mesoamerica and then traded up into North America. They'd make mounds in the early springtime, and they would plant corn in the top, and then let the corn grow up to be about a foot high, and then they would plant beans along the edges of the mounds. And you know, beans have these nodules that are nitrogen fixing, that have a bacteria in them that fixes the nitrogen out of the atmosphere. And so the beans were literally feeding the corn in the roots of the mound, at the same time that the beans were these climbing beans that climbed on the scaffold of the corn plants. So that's why it's a symbiosis, because each one is giving to the other. And then between the mounds, they would plant squash. And you know, squash has these big old leaves, and it would help keep the water in and keep the soil from eroding away, and would also keep the weeds down. So I've grown a Lenape garden like this for, I don't know, about 15 years now, and they're really productive. They're super productive. They're great, you know, corn, beans, and squash. These are all fruits that you can collect and gather and dry and then keep over the wintertime, because, you know, January, December, do you really want to go hunting? You know, do you really want to wade down into the water to get oysters or clams, you know? Dinner plate size oysters and clams? No, you know, you want to make some succotash. Of course, this is a kind of disturbance, right? And we're taught, you know, I'm sure if we go up the hill to the Forestry and Environmental Studies tool, you'll be talked about habitat destruction and deforestation. And this is it, you know, this is, you know, the Lenape would have a campsite, and then they would light fires and clear a field. And then after about 25 years, 20, 25, 30 years, they would abandon the field. That would become an old field, which is a kind of ecosystem type of its own, which then eventually would succeed to a shrubland, which then would succeed to a kind of forest. And what kind of forest would depend on the slope and the soil type and the disturbance history. And in this sense, this is how we can sort of reconstruct the neighborhoods of Manhattan. The neighborhoods in this context are ecosystems, but for the Lenape, they were just like our ecosystems of the city today. In the same way that, you know we can go to Chinatown and get a certain kind of food, or we can go onto the Upper East Side and see a certain kind of people, or we can go down to the theater district and do sorts of things. Like each neighborhood has its own configuration, its own kind of people, its own kind of place. Well, that was the same way that they would interact with these places, except that their notion of what those interactions were, of what their neighbors were, wasn't just people, but it was also mushrooms, and 600 species of flowering plants and shrubs and trees, 85 different species of fish, freshwater fishes, saltwater fishes, anadromous fishes going back and forth, some 350 species of birds, about 75 different species of mammals, including beavers. I always like to talk about beavers because, beavers are one of the reasons why the Dutch came, right? Because they wanted to kill these guys for their furs and make nice warm fur hats out of them. The way beavers make their lives is, I think, an analogy for the way we make our lives. You know, beavers are sort of hardwired by evolution that when they hear running water, they want to build a dam, right? And why do they want to build a dam? Well, dams allow them to move their food source around, which are these trees, right? They like to eat the inner cambium of the trees, and those are big things. So if you have water, it's easier to move them around, to float them over to your lodge. And your lodge, if it's in the middle of the pond, has a moat, right, that keeps away the wolves and the bears and the other predators that might eat you. So beavers, they do this for their own reasons, right? Of course, if you're a fish living in the stream, and you're a fish that likes running water, and beavers come along, and you think, oh, that's terrible. You guys just destroyed my habitat. Why did you do that? I can't stand that. But if you're a fish that likes slow-moving water, it's like being in a pond, you're like, beavers, that's cool, right? That's just what I need. You just made my habitat. Thank you very much. Of course, the beaver didn't think about it at all, right? The beaver was just doing it for its own purposes. And I often think that this is also a way of thinking about the way human beings modify the landscape. It's not like, we put this building here. It's not because we wanted to take away the forest that was here. It's because we wanted to have a nice place to give lectures in, right? That's why we put it in here, for people to learn. We had a purpose. We just didn't sort of think about what were the environmental consequences for the other things that might have wanted that building. There were wolves on Manhattan. There were wolves until the 1720s. There were black bears. There was a black bear shot in the 1630s. Teddy Roosevelt actually wrote a history of New York, and he talks about a mountain lion that the Dutch treed on the east side of Manhattan in the 1680s. There's another part of the project where I me and my students, we would read about the plants and the fish, and we develop species lists, and we would match up all the synonymies, and eventually come to this idea that there were about 1,000 likely species living on Manhattan. Not thinking about the insects, just the vertebrate animals and the plants. And that allowed us to do this third thing, which was to populate the island. So not just study its geography, but actually study its biogeography, its biological geography, to remember all these different residents. And of course, what connects species to each other and to the environment, it's the notion of habitat. And habitat for all species is the combination of just a few things: food, water, shelter, and reproductive resources. That's habitat. So, and that's the game of life. You know, in nature's world, if you have enough food, water, and shelter so you can grow up to be an adult and then reproduce, and your kids can have enough food, water, and shelter to grow up to reproduce, then you've won the game. You've won the game. So that's what a habitat is. Of course, every species has its own life history, its own ways of putting those things together. Our idea is that each one of those things is a map. What if you made the map of what wolves need, what to eat, and a map of where they get their water from, and a map of where their shelter is, and a map of their den sites? Well, the intersection of those maps would be the map of where wolves might be found. So that's what we started doing. We started reading habitat descriptions, like you might find in a field guide, and we started mapping them. So, you know, a beaver needs a slowly meandering stream with aspen trees and alders and willows near the water. That's the ideal beaver habitat. So we started making lists. So if I want to know where beavers are, I would need a map of the streams, a map of the aspens, a map of the alders, and a map of the willows. And that's good. But what about bog turtles? Well, bog turtles need insects and sunny places and other things, wet meadows. And what about bobcats? Well, bobcats need rabbits and beavers and den sites. And you'll notice a couple of things here. So just in this kind of made-up example, you can see that the things beaver need, bog turtles need, and bobcats need don't overlap with each other. Most things in nature don't need the things that somebody else needs, right? Because if they do, you compete with them, and that's not so good. So, you know, there's a lot of pressure in evolution to separate out the niches. This is another idea that Hutchinson wrote about here at Yale. But occasionally, there are species that are on the column here, like beavers. There's beavers there. And beavers, we have them because bobcats depend on them. But we also have beavers over here because beavers are something we're interested in their own right. And that actually makes the connection. So if you start playing this game out, you're like, okay, well, if I need to have aspens for beavers, well, what does aspen need? Well, aspen needs fire and dry soils. Or what does a wet meadow need? So a wet meadow needs beavers maybe, right? Beavers make dams and that creates wet meadows and maybe some other things. What does a sunny place need? Or what does a fire need? Or what does a dry soil need? And so for this part of the project, it became sort of Eric going around and asking all of his friends, you know, well, what does a beaver need? You know, you go talk to your mammologist friends. Or what do aspens need? You go over to the botanical garden and ask the botanist there. You know, what does a fire need? You know, you talk to a fire ecologist or a soil scientist. It turns out that, you know, in a way, that's mapping all the different aspects of the environment and all the different kinds of scientific disciplines where those might be found. And when you draw it all out, you get a sort of sparsely filled matrix like this. And in the Mannahatta case, it had about 1,600 elements going down through the floor and about 1,600 elements going out this way through the side of the building. A very large matrix. It turns out that this way of seeing the world is a very important way of configuring, mapping our world today. If this was Facebook and you and all your friends on Facebook and you and all your friends on Facebook and this was the pattern of the friending, that's what Facebook knows, right? That's a multi-billion-dollar business model. This is what Google's doing every night. You know, Google has these programs that are searching through the web. And it connects, it sees how are all the websites of the world connected to each other. And then it makes this network diagram and then has a very fast algorithm for searching through it. So when you type in, how to bake turkey or something, what it's doing is it's searching a network diagram like this and finding the most likely responses and then bringing that back to you. This is what the government's trying to figure out about terrorist networks. This is a representation of the way the power grid is organized. This is the way ecology works. And so because of that, there's all these kind of different scholars and disciplines in mathematics and computer sciences and sociologists and ecologists that are working about how do we visualize and see these networks. And so we were able to pick up some of the tools to map these, to actually map what we call the mirror web of Manhattan, the Mannahatta mirror web. So this is a little detail of that mirror web. Each of those different points is a different plant or animal type or a different stream type or a different soil type. And each of those gray lines is a different habitat connection between that thing and some other thing, some other element in the mirror web. Each documented in our database, right? So very specific. But you can see when you do them all that you get this very dense network of interactions. This is what makes nature strong. This is what makes nature resilient. If you take out one node, the whole thing doesn't collapse because there's so many cross linkages that allow any one thing to find some other way for it to survive. Something else that's important about this is that one of these nodes that's up here just behind me is the Lenape node, is the human node, right? Which is an important node. It has a lot of connections through fire and through horticulture and through fishing and through hunting. It's an important node, but it's not the only node for the first business. And the second is that node also depends on other nodes, right? Those people aren't independently living there and affecting other things. They're also dependent on all the other ones. One of the things that's wonderful about these network diagrams is that you can sort of see the world through the perspective of any one node and what it's connected to and what those things are connected to, or you can sort of zoom out and see it from this perspective. This is if we zoom out and see the whole mirror web. That middle ball there, that's the terrestrial plants and animals and abiotic elements, the things on land, because we're talking about an island. That sort of shoulder, that cluster over there on the left side, that's the freshwater elements, the things in the streams and the wetlands and the freshwater marshes. And then this cluster over here that's sort of off by itself, that's the marine elements. In the way that the sea is kind of its own distinct compartment in the network, and yet there are connections that bring it back. So we call these things mirror webs after John Muir, because John Muir said when we try and pick out anything by itself, we find that it's bound fast by 1,000 invisible cords that cannot be broken to everything in the universe. And this is the idea that's at the heart of conservation, to identify those networks, those cords, to make some few of them visible, and then to make sure that the most important ones last, so that the whole system can last. The mirror webs also allowed us to go back to the spatial domain, to the map domain. So we wrote algorithms, programs that reach into the GIS, that read the network and say, okay, well, for beavers, I need the map of the streams, I need the map of the alders, I need the map of the aspen, and I'm going to combine them all together, and I'm going to make the map of the beavers, which is the bottom right-hand panel over there. And then because all of those maps are based on that British headquarters map, and that British headquarters map is georeferenced to the modern city, it means that we can make the map of where beavers might have been 400 years ago in the modern blocks of the city. So, and this is the website that Priya kindly mentioned at the beginning, wilikia.org /explore. Gives you a sort of explorer where you can zoom into Manhattan and click on any block and get a list of all the plants and animals that might have lived in that block. The mammals and the birds and the reptiles and the amphibians and the fish and the plants, their probabilities, there's links about their conservation status. We show a picture of the kind of ecosystem that might have lived in that block. And we can watch people using the website, by looking at the web statistics, and like Google Analytics. You can actually see people spending hours just going block by block by block, because they can go, the first thing anybody does is go to their block, right? The block where they live or the place where they work, and they see what was there. And then they're like, oh, I wonder what was on the next block. Or the next block. And of course they know if you walk along the street, well, it's buildings, it's buildings, it's buildings, it's buildings. right? But if you do it on the Wikileaks website, it's, a forest, it's a slightly different forest, it's a slightly different forest. Oh, it's a salt marsh. And then suddenly all the species change, right? Because now you're in a completely different ecosystem. Yeah, it's really great. It's really trying to give people a sort of visceral sense of biodiversity in the geographies that they know. To say that on that block, on 61st to 62nd Street between Park and Madison, there used to be, 500 species that might have lived in that block. And now there's, people, dogs, cats, little sparrow, pigeon, It's not trying to say one's good or one's bad, but just trying to put them in opposition to each other in a kind of vital way that this kind of mapping can do. So I was very lucky in the course of the project to meet my friend Mark Boyer, who had a background in sort of digital photography and design. And he volunteered with me for 5 years to take the data that we were building for Mannahatta and reconstructing what Third Avenue, for example, looked like 400 years ago. So I would give Mark the topography, and then we would fill in the water and give it some illumination and shape the landscape, and then the map of the different ecosystems, which is that ecological landscape, that landscape mosaic, and then fill those ecosystems with little 3D models of all the plants and animals that might have lived in them. And that allows us to make these kind of images. And they're like what you see, on Avatar or Lord of the Rings or something, right? Some made-up movie landscape. But this is Times Square looking out to the west on September 12, 1609, right? This is a particular perspective. We can literally take a picture out of any window in Manhattan and reconstruct what that view would have looked like. So we can, paddle up the East River like in a Lenape dugout canoe and see Murray Hill there and see the water coming down at Turtle Bay, where the UN is. We can fly like a bird on the fall migration. We get these kettles of hawks that fly down the Hudson River. And so that's Mannahatta on the left and New Jersey over here on the right. There's that beach at 125th Street I mentioned before. And sort of understand how Mannahatta is a place that fits into a larger landscape, the landscape of the Hudson River estuary and the Atlantic Ocean and on the east coast of North America. Or we might even imagine Henry Hudson, right? So what happened on September 13th? He sails up the river a little bit. He moors. This is an image sort of imagining the sun rising that morning. There's Hudson's ship, maybe at 42nd Street in the Hudson River, the river named after him. And I love to think about Henry Hudson because, Hudson, he didn't mean to found New York, right? He didn't mean to do any of that. Hudson had one idea in his mind, and that idea was to get to China, to trade with China, to find the Northeast Passageway. And he was sure he was going to find it. I mean, that's why, he eventually died in Hudson Bay because he got in there and couldn't get out. So he saw the Hudson River and he got a glimpse of how, the Hudson opens up in the Tappan Zee and he thought, aha, this is it. This is the fjord to China. If I just go a little bit farther, China. And he got to Albany and had to turn around. Very disappointing for him. But I think what's ironic about Hudson is that there was something so precious right in front of him that he couldn't see. And that was Mannahatta, right? That was the Mirweb. That was this incredible example of nature with all of its parts. All the species interacting with each other, including with people in a way that could last for thousands of years. Something we don't have anywhere in the world today. Nowhere in the world do we have this. So precious, so valuable, and he completely missed it. And we live in a world where we have lots of things from China, right? But we don't have this anymore. The same kind of mapping, the same kind of visualization can allow us to see the landscapes where we live in a completely new way, to go down to that collect pond in lower Manhattan, see the smoke rising from the Lenape settlement, see the fields and the shrublands and the forests, see the salt marshes and 7 different kinds of forests and the beaches and the Hudson River, and to see that in the geography of the city today. Because of course it's changed, right? Yeah. And it's changed, much as Hudson had a value, had a vision, had a thing he really wanted to do, this world is the reflection of all the dreams that people have had living in New York City in the 400 years since, right? some of which were frustrated, some of which were accomplished, some of which built on others, some of which struck out in new directions. But this landscape, this configuration of ecosystems, is what the past generations have left us through the act of imagining what they wanted New York City to be. So that leads to this fifth and final act, which is about how do we imagine the futures to come for our city. And I want to suggest that it comes in part from seeing our lives in this long-term relationship with place. It's not just about us, but about our parents and our grandparents and our great-grandparents. And it's going to be about our kids and our grandkids and our great-grandkids. We have to see how we're going to live here over long generations, over 7 generations, like the Adonishani talked about. And not that one of these is better than the other, but they have to learn from each other. That I've really come to believe that the only way cities will survive in the long term is by taking the lessons that nature gives and building them into the city, into the way we construct the city. And at the same time, I think the only way that nature, what nature we have left, will survive is by talking about and helping people in cities see the value and the importance of nature for their lives. To actually see cities as a kind of habitat for people where they supply food and they supply water and they supply shelter and reproductive resources. You can think about that as education for our kids. And they do this fifth thing that arguably has been why cities have been built forever in the first place, which is to provide a sense of meaning. That place where new ideas can happen, where we can dream, we can talk to each other, where we can make fortunes, where we can lose fortunes. This sense where we, build faith and religion and government. Cities are at the root of all these things that we call civilization. And I think what's so exciting about this time in New York City and in other cities around the world is people are finding that they can find meaning not just in the church or in science or in art or in, making a lot of money, but they can also find it in the way their food comes from and where their water comes from and what kind of building they live in and how they treat their kids. So at the end of Mannahatta, I worked with an artist, Heidi Nielsen, where we took images of the city as it was in 2008, and then we tried to imagine what the future of those landscapes might look like. So Madison Square with streetcars instead of cars, and streams instead of storm drains, and red oak forest rather than London plane trees. But not trying to imagine the city without architecture or without people, actually trying to imagine a way of living an urban life that actually works in that place. And that scales, to scale up all of the Upper East Side with green roofs on every roof, and with a stream coming out of the reservoir and around the Metropolitan Museum of Art and winding down to the East River. Or even to imagine over some long period of time a redistribution of where people live and how we live in this landscape. It turns out that when we look at satellite images like this, like you could see on Google Maps, that the density of people living on Manhattan is 65,000 people per square mile. It's by far the densest place in the United States. It's actually what gives Manhattan, that magic of so many people in such a tight, confined space. It's frustrating, but it's also, exhilarating. But if you go out to New Jersey or even parts of the Bronx or out in Queens, you'll find communities that are 1,000 people per square mile, 65 times less. So Heidi and I thought, well, what if we grouped everybody at Manhattan density? Well, then they would only use up 38% of the area. And that means you could have farm fields again, you could have wildlife refuges again, even the water could come up a meter of sea level rise as we have here, and people could live. I'm not saying this is what we should do or this is the advisable thing to do, but this is the kind of thing that comes from thinking about the city as a landscape, as a mapped landscape of ecosystems that can be arranged in a whole variety of different ways. And I think we were so thrilled about this and the kind of responses to this that people really wanted to talk about these kind of maps, that then we went on to build an application called Visionmaker, which allows anybody to do this, anybody to play this game. It's free, it's online. It's a tool for what we think of as ecological democracy, this idea that we all have something to say about the place we live. And that the only way we actually create better ecologies is if we have a way to talk to each other. So Visionmaker sort of combines the science and this sort of experience of invention and creativity that we see like kids playing Minecraft, it's a Minecraft brick, and then sharing, this idea of using the computer to share ideas. So Visionmaker allows you to see the historical ecology of the city, to see the current ecology and then to make your own vision of the future ecology by changing the ecosystems, rearranging them, creating new ones, by changing the lifestyle of the people that live in your city, and by playing with the climate scenarios about the future. Do we imagine the future of the city this year, 2050, 2075, 2100? What are we thinking? And then see how the ecology would change in terms of what it means for the water cycle, the carbon cycle, biodiversity, and population. So I'll just close by showing you a few screenshots of the actual application. I invite you to go home tonight and try it out. It's completely free. You just have to make a brief account. So this is a map of the ecosystems of New York City today. This is a first draft of the maps of them 400 years ago. You can zoom in, say, to Marine Park in Brooklyn. You can see those ecosystems on top of the historical ecology for your neighborhood. We have these tools that allow you to paint the ecosystems. We have this sort of idea of raster painting where you get to actually change the ecosystems. You can choose the lifestyle of the people that live in your idea of the future. We have 5 lifestyles. We have an average New Yorker lifestyle. We have an average American lifestyle. We have an average Earthling lifestyle. We have a Lenape lifestyle. And we have what we call eco-hipster or eco-conscious. So that would be like all the students here at Yale, right? People that eat vegetables, people that ride their bikes, people that live in a little bit denser space. And most importantly, all the eco-hipsters, they choose to get their electricity from renewable sources, which any New Yorker can do just by signing up with Con Edison. And that does dramatic things for your carbon cycle, by the way. Anyway, and we have 6 climate scenarios. And then what happens is the model runs and it compares your vision in terms of water, carbon, biodiversity, population, and we're playing around with some economic stuff now in terms of what that landscape will look like in 1609 and today, and your vision going into the future. And then if you like your vision, you can share it with everybody else. So this isn't the end all and be all, and there's a lot of things that have to be made better about this, but it's trying to use the power of the internet, the power of technology, the power of all the things we understand about ecology to map a better future, and not for just me to say or a professor to say, but actually for each and every one of us to take the responsibility to create that future together so that all of us can live together. The skeptical, the intrepid, the imaginative, and the tree into the long-term future of New York City. Thank you very much.
Thank you so much.
Sure.
Thank you so much for an absolutely wonderful talk where you've tried to show each of us the sense of responsibility we have for the habitats that we live in.
Yeah.
So we open up to questions now.
Thank you very much, Priya. Also very happy to hear critiques and comments and what did we miss? What can we do better? Just going to get a drink of water.
Thanks very much. I may have just missed this in the talk, but you got the topography from the British map,
Yeah.
and then you visited sites with the same sort of habitat types to get the species lists.
Yeah.
But how did you place the ecological communities? This was a maple forest and this was a hemlock to their location on Manhattan?
Mm-hmm. Yep, so in New York State, there's an ecological community guide that comes from the New York State Heritage Program. So there's a classification of ecosystems for the whole state. And each one of those describes, what are the kind of conditions that ecosystem depends upon. Where would you find a high salt marsh, for example? So we basically encode that into, a rule-based algorithm that says, this kind of ecosystems requires this sort of tidal level or this sort of slope or this sort of soil type. And then we use the MIRWeb to map the ecosystems. Mm-hmm. So, and the maps are actually probability maps. It's the probability in this 10-meter cell that this ecosystem might have been there. So, clearly for some cells you might have, multiple probabilities for different ecosystem types, right? Because that's the way nature works. And then, the thing we don't really, the thing we can't know for sure, we can get an idea about the geology and the topography and things from the old maps, from the historic maps and modern studies, but the disturbance is the hard thing, right? So that's where we use models to sort of scope out what is sort of the range of potential effects of lighting fires or of horticulture.
I'm wondering if it had any impact on sort of political, I guess, planning for city planning.
Yeah. So I think, I think we don't know yet. I'm kind of playing the long game, as you can tell, the 400-year game. So, I think in that sense it's been effective that the people talk about it all the time. I think it's hard for people to live in Manhattan if they've learned about Mannahatta and not have this reference idea in their back of their minds.
Does the Parks Department use the tools?
Oh yeah, of course. Yeah. And I compare our list of ecosystems with the set of ecosystems we have in the city, right? And we talk about what are we missing, what have we lost. There's also, what really brought it home though was Hurricane Sandy, because if I don't have it with me in this PowerPoint, but if you compare the map of where the former salt marshes are and the areas that flooded in the city, it's like a 90% overlap of the two. And that's very clear. And it's funny, like the number one response I would get from people when I would show that to them is, oh, that makes sense. And I was like, well, if it makes sense, then why did you allow your house to get built there, right? Why did the city allow that? Which is exactly what the conversation is now, right? About what New York City should do about sea level rise and climate change. The thing is that most of us didn't build our individual houses. Most of us bought a house from somebody else that was built there sometime in the past, right? And in some cases, like in Lower Manhattan, it was 300 years ago or 350 years ago that landfill happened. And now, and then somebody built a low house, and somebody tore that down and built a bigger house, and now we have a skyscraper there. That's a problem. Like, what do you do now, right? It's not it's obvious to see the problem in light of the historical ecology. It's another thing to actually think about what is the proactive solution. And in fact, I think New York City is trying, but it's so hard to balance all the things that they have to balance that they really have not made a lot of success in making the city more resilient in terms of the next hurricane.
Thank you very much. I really enjoyed it. And I'm wondering with the Visionmaker app and mapping, if there's any, you just used the word proactive, which is what I was going to use, tips or suggestions for people to how to reach their vision. So like ways to lower your carbon footprint or things you can do to keep nature, bring back maybe nature into the neighborhood. Are those integrated or will they be?
There's a little bit of advice, but I'm sure we could do a lot more about that. One of the functionalities we built out, particularly thinking about schools, but it's been used in other contexts too, is a kind of challenge functionality where somebody can pick an area of the city and then set goals. Like, I want to reduce greenhouse gas emissions 80% by 2050, which is our climate change goal. I want to, increase the pervious cover by 10%, that sort of thing. And then, people can make different visions that meet that goal, right? Because there's, as you suggest, different pathways to that. We did one. We had a kind of mapping. What would you call it? Like a sort of map-o-rama at the zoo, where we had middle school kids all over the city create visions and then bring them together to talk about them. And the goal was around the 80-50 goal. And this one kid gets up and he's like, "This is just impossible. You just can't do it. Just can't do it." And then one of the other kids said, "Did you change the lifestyle? It's really important to change the lifestyle, right?" So, in science often, I think in science we often feel like, we need to figure it out and then tell people what the right solution is. Visionmaker is a little bit the opposite, which is sort of create the platform and then let people play to discover what the solution is. Maybe with a little bit of advice, as you suggest.
So, to what extent are the historical ecological communities and ecosystems of Manhattan represented in the city's parks today? Are the parks anything like an accurate representation of what was there, or is it something completely unique and novel?
Well, it varies a lot, although it's surprising how many natural areas there are left in New York City. I'm involved with an organization called the Natural Areas Conservancy, which is an organization dedicated to the 10,000 acres of natural areas in the city parks. These are the areas that, like, if you look at the park maps from the 1960s, they're like not yet developed. the place where they haven't had enough money yet to build the baseball field or the basketball court or whatever it is, but now they're forests or they're wetlands and they're valuable to us. So they did an ecological assessment of all the natural areas in the city 3 years ago, and then they mapped it against the Heritage Program ones, ecological communities, and I think you don't hold me to the exact results, but it was about 35 the different ecosystems, including a few novel ecosystems that are not in the classification system. So our and that was citywide. Manhattan had about 54 communities, we think. Our Wallachia mapping is coming in closer to 130 different types. Well, okay, so, it's a little biased. I live in the Bronx. I live on City Island, and there's a beautiful park, Pelham Bay Park, that's right beside City Island. It's 3 times the size of Central Park, has a wildlife sanctuary in it. And if you go out to Hunter and Twin Islands, you'll feel like you're in Maine, but you're in the Bronx. It's really fantastically beautiful. Big trees, rocks, sparkling waters, lots of wildlife.
Do you feel that that's attributed to the new expanded use of the Ubers and the Lyfts in Manhattan?
Well, I didn't hear that statistic, but I would attribute it to the Clean Air Act. Yeah.
Are you selling this book at Barnes & Noble here?
Well, I'm not personally, but Barnes & Noble, I hope, is.
Fair enough. And are you doing this in conjunction with the Botanical Garden program that they have?
Here at Yale, you mean?
Yes.
No. Yeah. But I'd be happy to come and talk to the Botanical Garden people.
I think you should do the presentation over there and with the FE Film Festival.
Thank you.
I'm going to take that as an invitation.
Yeah.
Thank you again for the talk.
Sure. Sorry.
Oh, yeah, I'm over here. Hello. So I think when thinking about maps and environment with the past, the present, and the future, that past vision can be dramatically different depending on what your baseline is.
Sure.
And I think it's really fascinating to hear about all the information and the maps and the history we have of this Henry Hudson September day.
Yeah.
And that being this theme and this baseline is cool. But I wonder, looking at the Visionmaker maps, how different that would look like if we looked at a baseline prior to that, or maybe somewhere in the middle of the 1800s. And certainly it would take a lot of effort on your project's part to create fully formed baselines for other years.
Or your part.
That's true. Yeah, it gives me something to do. But have you heard that being like a dialogue that's happening with people who have interacted with the tool or people that you've worked with about maybe the difference if that Henry Hudson Day wasn't the baseline this project used?
Sure. So I think there's a couple threads you're pulling on there. So of course, any moment in history could be the baseline, right? There's nothing magical about 1609, except that is the moment that people have been imagining for 400 years, right? So if you read The Great Gatsby, that closes with, him imagining that moment, right? There's all these 19th century kind of romantic paintings of that moment, and one can argue that that's a really important historical moment, right? Because that's where we shifted cultures. It's also a hugely important ecological moment, right? Because that's when Europeans come and they bring their pigs and their domesticated animals and domesticated plants. That's where they start messing around with the Lenape, and the Lenape stop doing their things. So the reason we picked it is, just like when you're writing a history, you can't write about everything that happened through history. You have to pick a time. Just like when you make a map, you can't map everything in the world. You have to pick things to map. We picked it for a particular reason, and that's a conservation reason. Because we want people, when they imagine New York City, to remember these images, for it to be seared on their minds in a way that they will never forget. Because we want people to remember that is the truth. That is the sort of the ecological truth of our place. That's why we can live there, is because of this amazing ecology that was there. And that's what we need to recover everywhere in the world, right? That's the whole conservation purpose. So yeah, so sure. When I talk about Wiliki, I show like the shoreline, during the height of the glaciation, and it was 120 meters or 120 meters lower and 100 miles offshore. And I talk about how the shoreline came in as a way of sort of, we only have to deal with a meter of sea level rise. The landscape dealt with 120 meters already, that kind of thing. I mean, you can tell those sort of stories, but yeah, that's why we picked the 1609 moment. Yeah.
Thank you so much. I've been so excited listening to everything you've been opening up to me today.
Thank you.
And in doing so, I was thinking one thing, you mentioned how we New Yorkers don't look back. Mm-hmm. And then the incredible photographs you're showing me of how you could show me what it looked like in 1673 or 1812, and that is so exciting. And I think of downtown Manhattan, a great grid, and every grid has one intersection and they all have posts. And I could just vision at least like 11 by 17 or a picture of that, protected from the elements, and on each block, on each intersection.
Yeah, that would be great.
And just the picture and like the date.
Yeah.
And as people would walk through the city, tons of people walking through the city, they'd see that photograph and go, oh. And it would just be exciting, and it would start to let them think about where they really are.
Right.
Would you see that be a possibility if some very wealthy, New Yorker decided to fund it?
You know anybody like that? Well, yeah. I mean, one of the great things I think, to bring it back to the theme, is instead of imagining these as just one map, but imagine them as this sort of this whole set of data resources, right, that are expressed in space. And so I'll just give you an idea of some of the kind of more artistic things that people have done, taking up your theme. So 2 years ago, I was contacted by this guy, a student from the School of Visual Arts, SVA downtown, and he was working with somebody at the Cornell Laboratory of Ornithology, and they were picking a few points in Manhattan, like the Cluck Pond and a place on the High Line, and they were looking at our distribution data and then matching it with sounds from their archive of those species, and then doing it in a 360 kind of way. So if you face this way, you would hear those kind of birds and those kind of wildlife. If you heard this way, you would hear the ocean, you would hear the Hudson River. It was really beautiful, and they took me out, and you could put these very high-end earphones on, and it was so amazing, like so dramatic, like so much so that I remember standing on the High Line and like looking out down 10th Avenue, right, that amazing view, and then hearing the sounds of 400 years ago and almost feeling sick to my stomach because of the cognitive dissonance of the two, right? We've talked about like local radio stations that you would tune into as you go around the city, and that the sound changes as you go around. People have talked about just kind of the visualization. We tried to get the MTA to loan us some of the bus shelters. This is back in 2009. That was when they were first putting in those beautiful glass bus shelters now, and those are in specific places. So we said, well, if you can't sell the advertising, can you let us have it, and then we'll make an image of that place. So you'd see it walking down the street. This sort of thing. Or I once talked to this designer, and he had this idea of like riding on the Circle Line tour, and there would be like a large screen TV, and as this boat went around, it would be showing you what that would look like, just on the TV, so you could like look around and like that. There's all kinds of wonderful things to be done, I think, with this kind of information. Yeah.
Thank you so much for the talk. So this work you're doing with Mannahatta and sort of like this establishing like a reference ecosystem for all of that, I'm wondering how that goes into conversation with other work you've done in like novel ecosystems, which are sort of essentially ahistorical. And when you look at sort of conservation in a place like this, how do you see those two things interact?
Yeah. So I don't know if you know, but the notion of a novel ecosystem is an ecosystem that people have made, and they've changed it so much that it probably can't go back to where it used to be. And many urban ecosystems are sort of in this. They would just require like just a ginormous amount of effort in order to put it back where it is. So, I mean, in my own mind, there's a couple different avenues. So one is, well, that's why you got to conserve the places where they are, right? That's why conservation of wild places is so important, and wildness at sort of every scale, whether that's a natural area in a city park or a big wilderness area in Canada or in the Amazon or something, right? That's part of the answer. Another thing is that I think urban ecosystems are just as important for their connection to people as they are for the ecosystem services they provide, that sort of thing. So, like we know that, children respond strongly just being outside in nature and having sort of unstructured play in nature. It doesn't have to have the exact species composition for that to work, right? I think we need to think about conservation as this sort of dialogue between conserving the things about nature that we want to conserve, but also conserving the human relationship to that nature. And so, any place can serve a role in that. Not every place has to do the same sort of thing. So that's the way I think about it. And then a lot of my work today is thinking about long-term futures for the planet. Like, what is the planet going to look like in 2100? When the demographic transition is complete, when 80% of people live in towns and cities around the world, when extreme poverty has been eradicated. That's going to be a completely different world for conservation. And that might be the time where we go back and start to think about what we can do for those novel ecosystems.
Hi. One thing that sort of troubled me about your presentation was early on, you referred to the Lenape as collapsing. It felt a bit agentless, as if it wasn't the Dutch who basically caused them to collapse.
Yeah.
So with that in mind, I'm wondering whether you engage with, or whether there's not a way to engage with in the forward-thinking work with a more agentful view of climate change, that this is happening because there are people causing it. I mean, as your other book showed, after oil and cars and subways,
Yeah.
these are not accidents or magic. And I know that's a bit of the lifestyle angle that you brought in, but I feel like there still is more of an agency to be brought in for something like corporations, like introducing children to the idea that there are people doing this.
Right. So I didn't mean to suggest that the Lenape collapsed on their own or that was inevitable. That was just me being brief, I think, in that larger scheme of things. So I can talk a little bit more about that. So, the way we understand is there were people in the New York City region for 8,000 years. It wasn't the Lenape the whole 8,000 years, right? There were probably many, many different cultures. We don't know exactly when the Lenape culture sort of formed, maybe about 1,000 years ago, near the sort of middle to late woodland period. So let's say 1,000 years Lenape been living there. And, doing the kind of activities I talked about, but actually arguably increasing the biodiversity of the land. Again, not purposefully probably, but through creating new ecosystems, right? Actually creating meadows and creating old fields and that sort of thing. And modifying the forest structure through the use of fire and those kind of tools. So, what happens when the Dutch arrive is a really fascinating cultural story because, what they wanted was specific resources, right? Like beaver skins, beaver pelts. And so what would they give for that? They would give things that the Lenape didn't have, like a hatchet or a blanket or alcohol, these sort of things. And what that meant was, before that kind of market sort of economy is there, the Lenape, there would be no purpose to kill a lot of beavers, right? Because what are you going to do with a lot of beaver skins, right? But once that happens, and the consequence of that is if you don't have a way of like acquiring wealth in sort of infinite kind of way, right? And you're living a lifestyle where you move 3 or 4 times a year and you don't have any, domesticated animals to carry stuff for you. You have to carry everything you own. What you actually want to carry with you is the respect of your community, right? So if you were an old guy like me living in a Lenape community, the ideal thing would have been you did right by your neighbors all the way up and, so that they respected you, when you're an older person. When the Dutch get there and they say, I want as many beavers as you can get me and I'm going to give you this cool hatchet or this pot, what that gave, and this is what Cronin writes about, is that gave a lot of power to the young people, right? And it sort of, turned over that relationship, so that weakened them. The Dutch brought domesticated animals, pigs. We know that there was a lot of conflict around pigs because the pigs would run into the Lenape corn gardens, very destructive. They didn't like that, so they would kill the pigs. The Dutch didn't like that. There was a kind of nasty guy named Willem van Kief in 1642 that came in and had sort of a iron idea about Dutch sovereignty, and so he started a war basically, which ran for 20 years and terrible atrocities on either side. And the ultimate was that the Lenape fled to outer parts of Brooklyn and Queens from Manhattan and down into New Jersey and Staten Island, and then eventually they lost their land there, et cetera, et cetera, et cetera, and then. Their story is similar to many, many Native American stories, in U.S. history. It's just they lost really early. Yeah. which is why I wanted to emphasize that they're not gone. They're still here. But they're also a difficult community now to interact with because there's, still have these sort of long-term fracturing. So, I've met with and talked to them, but, there are two Lenape nations in Oklahoma that don't get along with each other. There's some recognized people in Wisconsin and up in Canada, and First Nations, but there's some unrecognized groups. They have a lot of difficulties. It's a really problematic history.
So to close out, if I might ask a question.
Yeah, sure.
I was just wondering, is there a way to visualize how dramatically humans have been able to impact and transform this one template ecosystem?
Yeah.
Just as a way for sort of advocacy for climate change, given that we still have people who seem to not believe in the human-generated activities, distorting the pace.
Right. I mean, I guess the whole shtick with Mannahatta is just to create these juxtapositions, right? And not to fill in with too much commentary about why it happened, but actually say it was this, it's this now. That does a couple of things for you. One, it suggests that it's not just one. I think most people live in the city and they just see the city as it is, what it was when they came there, and then that's what they think it should be in the future, right? But if you just put two, then it suggests some sort of continuity or some sort of transition. It suggests there's a third thing, right? And then to show such a dramatic change, I think also helps, right? And then the way I talk about it is seriously not like one is necessarily better than the other. I mean, I love New York City as it is today, and I would have loved Mannahatta. And I think we need to find a way for the world to be big enough to have both great cities and great nature.
I was just very curious in sort of the Muir Web visualization.
Yeah.
If some nodes start pulling too hard, I mean, can you see that visually somehow? Because I think we're all, all of us scientists and I guess most of the population is quite stunned at how our agency has not been understood or appears to not be understood by a lot of people in power.
Yeah, we don't know how powerful we are, do we?
Right.
Yeah. But also I think, what's so interesting about our time is that we've never been as smart. We've never had as much knowledge and information as we have today, except for maybe tomorrow, right? All the papers that all the professors are writing now, for tomorrow. But, and yet somehow we still don't have the wisdom to act on that, right? And in New York City, I think it's really the sea level rise and the storm surge is where this has really come to bear. Like, it's pretty clear from an objective, as far as the objective scientific perspective, that some places are going to have to move or be redesigned entirely. But how you work that out in the social systems, that's what we're trying to figure out.
Well, let's hope that your vision helps social systems take the right sorts of decisions for the coming 50, 100 years. Thank you so much.
Thank you.
For
Thank you very much.
so we have a